half an hour or a little more, I will give you a getting started into the scripting features of UDE, and I show you how you can use Python scripts and Python commands for automating your debugging and test tasks. I have divided this webinar in 3 main topics. The first few minutes I will have a look at we will have a look at some principles that we need to know if you want to script the UDE debugger. Then I will switch to the tool and go through an example of a simple Python script step by step that is intended to test an application. And finally, we will have a look at the Python console of the UDE, which can be used to enter Python commands directly and also run scripts even during an interactive debug session. So, okay, then let's get started. In general, the purpose of the UDE scripting support is to automate debugging and testing. And that's the reason why we call this a UDE automation. The typical way of work is here that you can control the debug tool, the UDE, by another software, for example, a script or something like something else. The UDE automation feature is part of every base license of UDE, and that's the first good news. It comes without no additional license fees. The heart of the UDE automation is the UDE object model. That is an open and flexible software API which provides access to all the debugger functions. The object model is based on component object model DCOM from Microsoft, which is deeply integrated and widely used in the Windows world, and provides a standardized interface for inter-process communication, also inter-application communication. The COM can be used together with many scripting and programming languages, and that brings us or gives us a lot of benefits here. So you can see here that also on that picture, that scripting is only one part of the usage of the object model. The object model can also be used for coupling third-party tools, so it provides the base technology for that. So you can, for example, attach a test tool from a third-party vendor to the object model, and then, of course, to UDE to directly test on real hardware using all the debugger functions. So you can, for example, control the target device from the test tool directly and also access variables right into memories, etc., and such things. And there comes the first news here, because we rely on the Microsoft COM. We benefit from several advantages. We do not need a proprietary scripting language in UDE, nor we are bound to a specific scripting language. That means you can use any scripting language you like. You can work with your existing knowledge, with your preferred tools, and you don't have to learn any new syntax. Despite this, the examples I will show you in a minute are all written in Python, because that's at the moment one of the most popular scripting languages. And I think most of you are already familiar with that. This picture here shows an excerpt of the object model in UDE. As you can see here, the object model is composed out of a set of objects. That's why the name. These objects provide interfaces that give you access to almost all the debugger functions. As you can see here, this is composed in somehow a hierarchy. If you need the functionality of a particular object, you have to start from a top-level object that provides access functions or properties to get the next lower object in this hierarchy. And then again, you ask for the next level, and so until you finally get the object that you need. At the very top, there are two objects that are used in all the scripts as a starting point. The first one is the UDE launcher that is used if you want to create a new debugger instance. So this is what you will use to start the UDE. Or you use the UDE running instance manager. That is if you want to connect or attach to an already running UDE. From these two top-level objects, you get the UDE application object, which is the actual root object in the debugger object model. And from that, you can obtain all the other objects that you need. And these are the first few objects in the object model that provide the debugger functions. There are a lot more, but it would not fit here in that screen to show all of the possible functions of the UDE object model. All the objects provide get methods or object properties that can be used to obtain the next lower objects in the hierarchy. So this is illustrated in this little 4-line Python code here. We're starting from a running UDE. We use the running instance manager, use the get instance method to get the application object. And then from the application object, we use the workspace property to get a workspace. A workspace is basically the debug session, which contains everything you need to do debugging. In an interactive debug session, you create the workspace from scratch, load the application, and so on. But in this case, we have one already existing. And if once we have the workspace, then we can get the debugger, the core debugger for, in this case, the first core here, which provides us again a lot of functionality, for example, to start the application using the go command. Each of these objects implements methods or functions and also provides properties. This is a screenshot of the documentation for all the methods and all the properties of the debugger object. On the left side, you see the functions for doing something, and on the right side, you see the properties for getting or for setting something. The screenshots are taken from our help system. I'll show you later the help system in more detail. So we see that each of the objects and functions and also the properties are well documented, and you can click on the blue highlighted names, and then you get more detailed information about the functions and properties. For example, how the definition looks like. Here on the header, you see the definition for the read variable method of the debugger object in a more generic form. You get also a description text which explains what the function is doing, which parameters are used, and finally you have some code examples here showing you how to use the specific function or property in the scripting language of your choice. In that example here, using these stuff in Python. Okay, now we know about the principles and how the help looks like, and that can be used to write our first script. What we want to do here in the script is to run a quick test for a simple application. The application is a simple clock, so we're counting seconds, minutes, and hours, and we want to test the wrap around when a minute is up. So we expect the seconds are reset to 0 and the minutes are incremented by 1. The application under test is running on an Infineon Aurix. The hardware setup is shown here. That's on my table here. And I use the UED 2 Pro from our Universal Access device family to connect via the DAB interface of the Infineon Triboard. And the UED 2 Pro is connected to my PC using USB. For developing the script, I will use the Anaconda Python distribution and a very nice tool named GPython Notebook that allows us to interactively develop Python scripts. Okay, and then let's jump to the UDE. First of all, I'd like to show you how to attach using a script to a running UDE instance. UDE is open, and the first thing is what I'd like to do is to open in workspace. So I prepared already a workspace. So if you are not familiar with the concept of workspaces and how to create one, I'd like to refer to the webinar which was held 3 or 4 weeks ago. So you can look at the Hitex YouTube channel to find this webinar about multi-core debugging for the Aurix. And there I explained how to create a workspace from scratch. So we use an already existing workspace. I opened the workspace. The workspace also already contains the ELF file as well to be loaded into the target device, into the Aurix. I flash the ELF file, and then we want to start our test. I'll show you the function that we want to test is the update seconds function here, which is quite simple. We count or we increment the seconds, and if the seconds equals 59, then we reset the seconds and update, call the update minutes function. Okay, then let's put it on the left side and open the GPython notebook, which is a web-based application that can be used to write some Python scripts. So you have some cells here, you can enter some Python code, and then you can execute every cell, and that is very useful for our webinar today because I can show you each single step. The first step, what I want to do is not to show you how to write the script, but how to get the help for scripting. So in UDE, we have a help system, and in the chapter UDE common components, we find the subject chapter programming, where we find all the information about the object model. For example, a getting started, some getting started examples, and also the reference. And you may know, okay, this is very familiar. I used this picture already, and this gives you the top level objects of the object model, the documentation for that. You can click, for example, on the workspace. You see all the functions or the properties. You can click, for example, now on the get core debugger function. You get the help for that and so on. And for example, here the core debugger returns the debugger instance. And you see here which is what kind of object you get. The object is UDE debugger interface, and then you can click on it and you get the information. And that is the way you obtain the function objects for your debug task from the top level objects. Okay, then let me close that and show you how it works in the example. The first thing is what we need to do in every script to load some libraries provided by the Python. The most important ones for us is the win32com.client library, because this is used to use the Microsoft COM in the Python script. We execute that, and then we need to look for the running instance manager, because we have already a debugger opened, and this can be done via the name of the running instance manager and asking the COM object or the COM functionality of this Python module here to get the running instance manager. And we check here if we have found some. You can already also open several instances of UDE, but in this case we check if there is one available. We run this script. Okay, everything seems to be okay, and from that we can now access the UDE application by getting the first instance of the running instance manager to show that we have a successful access to the UDE application. I print the version information, and then we get the workspace from the UDE application using the workspace property. Also, some information should be printed out, and then we wait for connecting. Okay, we are connected, so I expect that we have no issue here. We run this as well. So you see we are attached to the next major version of UDE, which is not yet published, but in a few weeks we will release that. And the workspace that I use, and the indication that we are successfully connected. From that, we want to start our application. For that, we need to get the core debugger for the core 0 from the workspace. We can write the name of the core, or we can also enter an index number here as an argument. And then we like to start the application by using the go command of the core debugger. I do this, and then you see, okay, application is now running. We see some variables that are changing during runtime, so it's a good indication that everything is working as expected. And then we want to write our actual test. For that, we need to enter some test values and to check the results. And before we enter the test values, it's a good idea to stop when we entered the update seconds. So we need to set a breakpoint at the very beginning of that function. And for that, we obtain the breakpoints object, which contains all the breakpoints for the core 0 from the core 0 core debugger. Then we add a breakpoint at the update seconds function, and wait for the application that hits the breakpoint, hopefully. Okay, we did this, and we set the breakpoint, and instantly we hit the breakpoint at the very beginning. Now you can write some variables. For example, the test case that we want to test is the seconds are at 59, and we also define, or we enter, or we want to inject a specific value also for the minutes to check the increment of the minutes. If I run this, then you see, okay, the variables has been written, and we want to also print out the written variables. So we read these variables using the read function, read variable function, and we save the read minute value in a variable that we used later for the for comparing the test results with the expected results. So we print out, okay, everything seems to be fine. So we have on the target written 59 and also read back, and minutes also written to 10 with 10 and read back also with 10. So now it's time to proceed in our test. For that, I remove the breakpoint and set another breakpoint at the end of the function. For that, I can use a remove function in the breakpoints object with the name as a specifier for addressing the right breakpoint, and we set with the already known method the breakpoint at the end. This syntax is the very beginning of the function plus 8 lines. Then we run this. So we see we remove the breakpoint, we added a new breakpoint, and then we can proceed the test by a go command and wait that the target is halted at the next breakpoint. Then we can also look at the variables. So seconds is reset to 0, and the minutes are incremented by 1. And this should also be checked in our script. So I use the read variable function of the core debugger to read the test results, the seconds, and also the minutes, print the results to the console here, and this is the actual test. So we check for seconds equals 0 for the reset of the seconds, and also we test for the increment of the minutes, and this should be okay. So seconds is 0, minutes 11, and the test has been passed. So that's all. Finally, it's a good idea to clean up everything. So we remove the breakpoints and we start the application. And the most important cleanup is to free all the used objects at the very end, because if you do not free all the objects, then if you close the UDE, it may happen that the UDE remains running in background because the objects are not are already in use, or UDE thinks that the objects are already in use. So yeah, clean up all the used objects, the breakpoints, the core 0, which is the core debugger, the workspace, the application, and also the running instance manager. We run this, and then we can close the UDE safely. Okay. That is an example how to attach to a running UDE. So we want to change the script a little bit to open a new UDE, to create a new workspace, and to load an application. For that, I change a little bit the code here. So we don't need the running instance manager anymore, but we need to get access to the launcher using the same method. We ask the Microsoft COM for the UDE launcher, and then we prepare some variables that gives us the current location for our project here, which is the working directory. Then we want to have a workspace name here, which is that one, which should be saved in the working directory. And in the working directory, there is already a target configuration file, which is used to connect to the tripod on my desk. We execute that, so all the variables are now initialized, and then we create a debugger instance. So I remove that, and we're using that code here to create the debugger instance or the debugger object by using the start and create workspace function of the launcher. UDE-exe is the command to open the UDE. We provide the name for the workspace file. We provide the target configuration file that needs to be existing. And we tell the function that we want to create a new workspace, even the file is already present. We run this, and then the UDE is opened. We have a successful connection. And then we start debugging or start our test. I need this here by getting the workspace, getting the core debugger, and execute this. We are connected. Okay, was quite obvious because we can look at the message window here, and we have now the access to the core debugger of the core 0. And then we cannot make it go at this point here because we need to load an application. And we have also a method in the core debugger that allows us to load and flash an application. We provide the ELF file and load it into the target device. We execute this piece of code here. You see, okay, we have the code loaded here. We have also some source code here in the debug tool. And for now, we can use the remaining stuff to start the application, to set our breakpoints, to write the test values, to read the test values because we have not opened any watch window with the variables right now. You see, okay, we have written 59 and 10 for the minutes, and we read out these, then we can remove the breakpoint as we used it in the previous demonstration, make it go again, and then we do the test or the check for the results. Everything is okay, and then we remove the breakpoints and make it go. The cleanup needs to be changed a little bit because we have different objects here. We have the possibility to close, for example, the UDE instance, and we need to clean up the launcher instead of the running instance manager. But the others are the same, and then they can run. The UDE is now closed, and we have cleaned up everything. Okay, that's how it works for attaching to a running UDE, or if you want to launch a new one and create a new workspace. You can also launch the UDE, load an existing workspace, and so on. So that would go beyond to the scope of this webinar, and because of the time I can't show you, and also I think it's a little bit annoying to look at this, but you can refer to our help system, and if you need more information, that we provide also via our support email address a application note for using the UDE automation interface and the object model. Okay. Python can also be used in an interactive debug session, so not by an external script, but also using it from inside, using our Python console. In the Python console, you can enter UDE commands in the Python syntax and also standard Python commands from the Python language. The API for the UDE commands is the same as we already know, that we have already used in the external scripts. But the difference is that some of the root objects already exist, especially the workspace and also the application object. The console itself features all the necessary functions that you use or that you want to have to use it in a convenient and efficient way. For example, you get the command history, you have auto-completion, you can have command things, or you can save command sequences that you entered, and you can run them later again, and you can also from inside execute complete scripts. For example, our test script that we have written. And yeah, at the end, I'd like to show you that I open the workspace again. So let me look for the workspace. That is the same workspace as before. So we flash the application, and then we can open the Python script console. I put it here, somewhere here, and then because we want to output something, I also open the console for output some information of the script. Okay, and in the Python console, you can use commands provided by the object model as we have it used in the scripts. For example, we can assign a core debugger to the variable core 0. You can use the control right key to get the auto-completion. For example, we want to access the workspace, get core debugger core 0. That's already known. Then we can make a go. You have all the available functions here. We can make it go. Then we see, okay, application is running. We can break the application, and we can also look into the history by, for example, using the control up and down keys. We can then also write variable. Was not the right one. Write variable, the name, seconds, and for example 59. Okay, and of course we can write or we can run a complete script. For example, a script that looks like the same as we used in the Jupyter notebook. Some minor changes are necessary, or I have done because we have already some objects available. We can instantly access the core debugger because the UDE workspace object is already present in the Python console. And then we have some wait functions here, because if I run the script without them, then you would see nothing because it's too fast. And of course, we have used no print. Some print methods are still there, but we want to output the important information to the console here, so we can use the console output function of the core debugger. And then let me start the script. You see, it's reset the target. It starts the application, sets the breakpoints, writes the variables, and then finally tests if the seconds are reset and the minutes are incremented. Quite simple. Okay, so you have seen that you can use Python as well as for external scripts using a Python distribution like the Anaconda. You can also do this from the console. I've not shown that. I have used the Python Jupyter notebook instead, but you can also use an internal Python console to enter commands using your keyboard, or you can run prepared Python scripts from inside the UDE. And that ends the webinar for today.